And welcome back to the morning show. It's Wednesday Wise Guy time. Our U of I pretty much genius physics professor Matt Sellin is here. We're not going to sing like the Muhammad Seymour guys do.
Don't ask me to sing.
Yeah, me neither, because I'll smash these light bulbs and probably have everyone running out of the building. But today we're talking about air pressure and going to break some stuff, right?
Well, you know, this was a kind of a last-minute deal because what happened last week was my old TV broke, and it's sitting right here. And it's a big old 27-inch flat-screen TV. And what you notice when you pick one of these up is that it's really hard to pick one of these up. I don't know if you've ever known that. And now, do you know why those things are so darn heavy?
It's weighted weird.
It's very, very heavy. And if you think about it, if you try to pick these up, the weight is all at the front. And the reason is that the glass that the thing is made of, the very front screen, is incredibly thick. And the reason is that, well, what's inside a TV?
There's picture tubes.
Right, and what's inside the picture tube?
Well, there's little people inside the TV acting stuff out, right?
That's right, running things around.
Yeah,
and also there's a vacuum in there.
Right.
Okay, there's a very high vacuum, and the picture tube has to be able to withstand the atmospheric pressure on pushing on the outside while there's a vacuum on the inside. And a flat surface is really bad for withstanding pressure. If you think about it, you don't see light bulbs that are flat. You see light bulbs that are round. The reason is something that's round can withstand quite a lot of pressure. And in fact...
So Edison knew what he was doing.
Yeah. And so first I have a demo here that's going to show you why you need to have a vacuum inside a television. Okay. And now, there are parts of a TV, the electron gun, the thing that's at the very back that produces the electrons that then become a beam that hit the screen and so on. It's just like a light bulb. The way you get electrons is you put current through a filament, it gets very, very hot, and electrons come out. And so what I've done here is I smashed, and this is something you should never do at home, by the way.
We have that on the screen right now.
Oh, good.
Don't try this at home, folks.
So here's a bad idea, which is a light bulb without any glass on it, but it's still intact. And so I'm going to plug this thing in right now. In fact, you can plug it in, and so zoom in on that thing, and you'll see what happens.
You ready?
Okay, so you saw what happened. It burned out. So it only lasted about a second, and you should probably unplug it, because right now... Otherwise, you know, we're going to touch this thing and get all jumpy. Okay, so there was a little filament in here which burned up. It got red hot, and then it just caught on fire. And so the vacuum is required so this thing lasts more than a second, because if there's no oxygen and no air in here, the thing can actually remain white hot without burning up. And the other reason you have to have the very high vacuum is that the electrons have to get from the back of the television screen to the screen itself. So you have to make a beam of electrons, and that would just scatter. If there was air in there, it would never make it all the way. Okay, and so air pressure is pretty big, and I know we've done this thing before, but I'm going to do it here again. Air pressure is about 15 pounds per square inch. Right. So if you look at the TV screen, is pretty big. There's a lot of square inches there. That thing would, there's an enormous number of, well, thousands of pounds pushing on that thing right now because of air pressure. And so here's a little demo of that. Here we have. I don't know if we have time for this. You can
we have 1 minute.
So. Oh boy, we have tons of time. Okay, so if you hang on to that thing and just push those together as hard as you can while I try to suck the air out of it with this little pump. Okay, here we go. It's starting to work. And so if I'm just sucking some of the air out, not even all of it, just a little bit. You don't have to push anymore now. You can let go. In fact, now that I've taken some of the air out of the inside of this thing, you can't even pull it apart anymore.
We've done this before.
We've done this before, and it's really, really hard.
I almost busted a vein trying to do this.
That's right, and so it's very hard, and if I let the air back in, it comes apart like that. The reason is that you have so much pressure, 15 pounds per square inch, pushing on this thing. Okay, again, notice this thing is it's a spherical shape, because that's good for withstanding the pressure. The TV screen, lots of glass, very flat, very bad shape for withstanding pressure. And what we're going to do when we come back is we're going to take a big hammer and we're going to smash that thing, and we're going to see just how thick the glass is.
For real? For
real.
Like Gallagher, except for no fruit but a TV screen?
Except way better than that.
Way better than Gallagher. All right, we're smashing TVs in 30 minutes, folks. You'll definitely want to see that. And again, don't try any of this stuff at home. And if you have any questions for our Wise Guy, you can email them to themorningshow@wcia.com or Matt's website, wiseguy.net. But now it's 6:53. Let's check in with Jennifer Ketchmark.